to wait till the next month as we've got a lot of interesting updates. Thought we'll just push it over by a week. And here we are. So let me go to the agenda. I'll share my screen. Okay. So I hope my screen is visible. Is the screen visible, Prithvi?
Yes, I can say it.
Yes.
All right, thank you. So this is the agenda that we have today. We'll be talking about the recent integration that we made with the Captain project. Jürgen will be presenting about how we can use Litmus to strengthen application resilience evaluation, and how you can use Litmus to strengthen your quality gate in the Captain pipeline. That will be followed by some discussions around a recent experiment that Jordi and Moti and Ondra have been working on from the Red Hat team on node level experiments. We've got node restart that was added in the last release, and we're adding node power off this time. So we just look at their use case and how they've been contributing. And we have a discussion around contributions to the CNF conformance resilience suite. So we have Watson here. There are some discussion points there. Thanks, Watson, for bringing those up. And I think Udit also has something to add from the Litmus side as to what are the efforts we've made thus far. I think we were a bit busy in some of these releases and deliverables that are generally aligned with the KubeCon. I think we found some cycles after that, and there have been some efforts around that. So we'll be happy to share those details. And we have some general discussion about the recent problem that we're all faced with around Docker pull rate limits and restrictions that we have. There are a lot of options available, in fact, many. We just want to hear out the community and your views and how you're planning to tackle that or what your views are. But I think importantly, I think we have a lot of new members on this call, and that's always exciting. Litmus as a project has been growing for quite some time, and a lot of the folks that are there as participants today, we've had interesting conversations with them on Slack. So it's awesome that they've taken the effort to look at Litmus, evaluate it and use it, and then contribute back to it and provide feedback. So we have a lot of them on this call today, so we'll be happy to introduce them. And if time permits, and after all this, if we do have some time left, then we can just quickly go through the release items of 1.10. That's the release that's just gone by, and items that are planned for 1.11. So with that, I think I want to keep the floor open for intros. A lot of participants today, I think, feel free to introduce yourselves. I can sort of help with, if there's anyone missed from the participants, I could just call them out, but please go ahead and introduce yourselves. We're all happy to know about you.
I guess I can start.
Go ahead. Oh, please go ahead.
Yeah. Hey, I'm Ho Chun. I'm a software engineer at DoorDash. I'm trying to build a chaos engineering solution for my company, and have been exploring Litmus for the past few weeks. Right now, still in a phase trying to understand what it can do and how it works. I guess my focus is more on security and observability stuff. So thanks, Kasik, for inviting me to this meeting, and I'm excited to see the community is getting bigger, and I'm just glad to be here. Yeah.
Awesome. Thanks, Vishwan. Thanks for joining today, and thanks for all those wonderful feedback and questions. I think goes to make the product much better. Thank you.
Hi, everyone. I'm Kelly Hare. I actually am part of, I'm employed by My Data, and I'm an enterprise architect here at my data, focusing on CI/CD. I came from GitLab and also on chaos engineering too. So definitely very keen on getting more and more involved and understanding what we're basically building together as a community. Thank you.
Awesome. Thanks, Kelly.
I'll go next. So hello everyone, I'm Samar and I'm working with Orange. So what led me to Litmus was actually we were looking for a chaos engineering tool for our resiliency testing. So we came across Litmus and it looked very promising. So we have been exploring it for past month and it is really looking good, and we are continuing to explore it, and hopefully we'll be able to build something great in our environment and would be able to use it. So and thanks a lot, Karthik, for your support.
Thanks, Samar. I think thanks for the contributions and the effort that you've been making in terms of getting the experiment right and trying to get the right details out of the experiments. So thanks for that.
I'll go next. Hi, my name is Jordi. I work here at Red Hat with Moti, and we're focusing right now on creating, evaluating the maturity of the KubeVirt solution. So we are developing our own chaos engineering based on Litmus, and we are tackling very specific cases for our platform. So I'm here just to later on I'm going to share about what we did for the node power of just specific use case for us. Hope maybe that you guys can see a benefit to it, and maybe can be enhanced or extended for other platforms.
Awesome. Thanks, Jordi. I think we've seen a lot of engagement, a lot of contributions across orchestration experiments from the team there at KubeVirt. I'm assuming that Mote and Andra are also working along with you. So great experience, co-reviewing the PRs and trying to sort of figure out the use cases, and really looking forward to your demo later today. So thanks for joining.
Yeah, we are in the same team, Mati and Andra.
Awesome.
I joined 1 month ago, so I'm quite new. Sorry, I'm done.
Yes. Hi, Ipshita here from Orange organization, and using this Litmus tool for our resiliency, our local environment resilient testing. So I'm also using this tool for last 2 weeks, and it's really very helpful. And I'm also getting some. I mean, I have also get some opportunity to contribute in Litmus. So thank you, Karthik, and Shubham also. Thanks, everyone. That's all.
Thank you. Thanks for joining, Nipsita. Thanks for the contributions. And yeah, I think the rest of us are regulars in Litmus. I think Jürgen, would you like to introduce yourself? Jürgen is a known face in the Litmus community, but I'll just let him introduce himself.
Yeah, thanks. I'm also happy to join first time here in the Litmus community, so thanks a lot. I've been working together with Karthik on the integration between a project I'm heavily involved in, and I'm a maintainer, which is called Captain. I will present this briefly today. And we've been working together on integrating Litmus and Captain and really evaluate the resiliency and helping to improve the resiliency of applications that you run on Kubernetes together with Captain and LitmusChaos. And yeah, thanks for the warm welcome, and looking forward to this community call.
Cool. Thanks, Jürgen, for all the effort that you've spent on the integration, and also I think defining a really useful integration. The use case is really helpful for all those that want to left shift and do chaos in their CI/CD pipelines. So great to have you in this call. Really looking forward to the demonstration again. I think Watson, Christine, Moti, Rahul, I think all of us, we have them coming on to the community call as attendees from previous time. Thanks for joining again. Thanks for bringing all your agenda items on today. So let's get started. Jürgen, would you like to take it away?
Oh, I was muted. Sure. Thank you. So I will just go ahead and start my screen sharing. Desktop 1 should be just fine. Yeah, here we go. Perfect. So Kartik, I also have your picture here on the slides. As, I think there should be a big shout out also to LitmusChaos, to Kartik, especially since you did a lot of work also on this integration, and it was really a pleasure working with you. It still is a pleasure to continue our work. And I'm really happy to present this also here in your community, because I think it really shows the possibility and like the potential of both projects, and that you can do a lot of things by combining those two. In the beginning, I just want to give a little bit of background why we did this and what it actually means. So we had to come up with a title, and this is the title of a presentation, and also Kartik did a great blog post on this. I also put a link later on in the slides, and I just want to give you a little bit of background. If you think that's useful, if you want to reach out, I put here my Twitter handle. That's an easy way to reach out, but you will also, or you can also find me on the Captain project, and I've also links to our project later in the slide. So what do I want to talk about today, or just show you? It's really about the evaluation of the resiliency of your microservices living in your Kubernetes clusters. And we think it's important to do this because just doing a functional test or performance test, load tests on these applications is not enough, because you won't find what would happen if there are any outages on your application. You will find if your application can survive high traffic, and if it's capable of dealing with a huge amount of users at the same time. But you would not really find out with functional testing or performance testing if a couple of your pods, for example, die, or if network just goes sideways. How would that affect your application? And with this, we might need chaos engineering and these tests by LitmusChaos. But we actually also want to evaluate this on a steady basis, and this is how LitmusChaos tests and SLO evaluation, SLO for service level objective evaluation by Captain, can really work together. And I will also show you a short demo. So let me just and I borrowed the slide from Kartik, but let me just talk briefly about the importance of this, because when you think of your modern stack, where you have your infrastructure, you have Kubernetes, you have a couple of other cloud native services, you have third-party services, and then you have your application. So it's not only your application that has to be resilient, but it's a lot of different other things. And you really have to check what does happen to your application if the other things might fail as well. You cannot be sure that each time you run your applications that your Kubernetes cluster will always be available, or that you always have enough capacity to schedule all your pods, or that all your pods will be available at all of the time. So there's a lot of dependency, and also here on the quote is more than 90% of resiliency depends on others or on other components, depends on maybe the infrastructure, depends on third-party services, or just maybe the orchestration layer underneath. So it's a lot of complexity, and we have to find a way how to test this. And here also Captain comes into play. So what is Captain? And I know it's might be a little bit overwhelming, this application, but let me, or this picture, but let me just start on the left side here. Captain is an application lifecycle orchestration tool. And we try to automate a couple of use cases for you. One use case, for example, is progressive delivery with automated quality gates. Progressive delivery is something like canary releases, blue-green deployments. This is what we think of this here. Then we have one use case, which is just to have, maybe you have already your progressive delivery, maybe you have your green deployments, but you just want to use quality gates. You need a way to really get a score of your applications and a quality score, and based on the score, you will allow it to promote to production or not. We have SRE-based automation that really means using these SLOs in all of the processes, and having SLIs and SLOs as the core concept. And auto remediation, that means that you can react automatically on something that is happening maybe in your production environment to trigger a remediation script automatically. And Captain is building this use case and automating these use cases for you based on configuration files, which are plain YAML files. And we will see a couple of files also in this demo. And being this kind of control plane and this orchestration tool for your app delivery, it can be connected to different tools. So we are using Helm for the deployments. We are using JMeter or other testing tools for the load testing. We have now this integration with LitmusChaos to execute chaos tests or to trigger chaos tests. We have integrations with Prometheus to gather all the data that is actually collected during these tests. And then you just, Captain comes up with this solution for you that orchestrates all these tools and will bring them together. So how is it built? Just briefly, it's not an operator in your Kubernetes cluster, but it's what we call the control plane, and it's event-based. So Captain will receive events and will send events. And this is how we did the integration with LitmusChaos. We receive the events to trigger the tests, and then we again trigger LitmusChaos by sending them the right cloud event. LitmusChaos is doing their execution and then sending back a cloud event to Captain so that Captain knows execution has been finished and we can move on with the next part in our workflow. It will also manage the different stages for you. Let's say a dev and pre-prod and production namespace, which are your different environments based on the Kubernetes namespaces. And it can be connected to a wide variety of different tools, but today we will just focus on LitmusChaos. And I will talk a little bit about in the demo of all these different components, but what we will see in the demo is actually a simple demo application. It's called the Potato Head. It's also committed to the CNCF GitHub repository, so you can also play around with this by yourself. This will be deployed by Captain into the chaos stage. So we have one stage, a single stage pipeline. I will show you how we set this up in Captain. We will use a Helm chart to deploy the Potato Head application to the chaos stage. Next, we will use Captain to trigger the tests, load tests, JMeter tests, for example, in this demo. But at the same time, we'll also trigger chaos. So we have JMeter tests to really put some load on our application, but at the same time, we're triggering chaos. And after the tests are finished, we are looking for the evaluation of the quality gate. So we are triggering the quality gate. This will reach out to Prometheus with query the data for this test run, and will then come up with an evaluation. And this evaluation is based on service level objectives. And these service level objectives will give us then a score, and based on the score, we can see if our application is resilient enough to be promoted, for example, to the next stage, or if we actually should rework or improve the resiliency of our applications. This will be the workflow of the demo. How is it set up? Everything for this demo today is running in the Google Kubernetes engine. We have installed Captain. We have installed Prometheus. That's also actually done via Captain. So Captain has an integration to configure and install different monitoring providers such as Prometheus. Then we have extended this with a black box exporter, which will check two different metrics. Actually the probe success and the probe duration, so we will check if the application is available. Our application is our Potato Head application. It has a little bit of delay in the startup, so usually it's a very small demo application and quite fast in the startup, so we set a little bit of delay in the startup so we can really play with evaluating the resiliency. And we have LitmusChaos installed, and we use one experiment, which is the pod delete experiment, and this will be killing a pod of our application. And we actually want to see if our resilience based on the probe success and the probe duration is fine. So with this, I am switching to my application. So I can already show you, it's the wrong part, maybe I have it somewhere. I guess I have to remove, yeah, here we go. So what I can show you already is the application running right now. So here it's called the hello service. That's the service of the potato head. I have already deployed it earlier today, and I can see it didn't got a very good score. But let me just do it again to check if it's already in a good score. And by the way, this is the complete definition for a single stage pipeline in Captain. Make it a little bit bigger. It's what we want to do is we have one stage called chaos. We do a direct deployment, so we don't do a blue-green deployment, but we just directly deploy it into the stage, and we want to execute performance tests. This is what we defined. And let me just, here we go, send a new event to the Captain control plane via the Captain CLI, and the event itself is, I want to deploy a new version. This is the version, it's version 0.1 and with a replica count of 1. So this is what I want to do. Here we go, I have a typo in here, it's actually Captain send event. I get a Captain context ID, which is basically the root event of the whole workflow that will be executed by Captain. And in the Captain's bridge, which is our UI, we can see what's actually going on. So we can see the configuration was changed. We have deployed this version. We can see the deployment is already finished. And we will just see in a second that the tests will be also finished. There is just a small, let's say, hiccup here in our UI that it doesn't indicate when the tests are started, but it's always the workflow. Once the deployment is finished, tests are immediately started. It's just that it's missing here in our representation. But now the tests are started. And we are executing, as you have seen in the diagram before, at the same time, JMeter tests to put some load on the service, and we are triggering LitmusChaos tests. We will actually see this here. We can see the hello service was just removed. This is Lens. It's an IDE for Kubernetes, which is quite handy. And we can see it's not yet ready. It was just there. There is a pod delete job that lives also in our LitmusChaos namespace. Basically, our Litmus is our project, and Chaos is the stage that I've defined in the shipyard file. And this one was killing our hello service. So now we have this pod. It's healthy again. It's up and running, and in just a second or two, we should see that the JMeter tests are finished. And once these the Litmus tests and JMeter tests are finished, Captain will do the evaluation of the quality gate. So let us check back in the bridge, since this is already finished here, if everything is finished already. And then we should be able to see the quality gate evaluation. And the quality gate evaluation is really based on SLI and SLO files. And maybe if it's not coming back, you can see I'm using, oh, here we go. I'm using nib.io as an external service. Sometimes that's a little bit slow. But anyway, we can already see it took about 2 minutes for the tests to finish. Captain was starting the SLI retrieval, and we have a finished evaluation. So the evaluation is comparing with the last, we can see it a little bit here, with the last successful run, which is the green run here. It's comparing this, but anyway, we can see our scores are not high enough. So we have defined 2 different SLOs, and we can see we would need a total score of at least 75%. for it to pass, we got 0%. We got 0% because both of our SLIs did fail. Our probe success percentage could not reach a threshold higher than 90 nor 95%, or the value of 90 or 95, and our probe duration was higher than 100. So it should be lower or equal than 100. So we found out that the resiliency of this version of the microservice is actually not satisfying for our needs. So what we could do is we could either tweak our SLOs, we could allow it to be greater than 370 or more, but actually we already set, this is our goal, 100 is our goal, and the probe success percentage should be higher than 95 or 90%. 95 would be full score, 90 would be still okay, but it would result in a warning. So what we will do here in the demo is actually we will try to deploy it, but change the configuration to a replica count of, let's say, 3, or we can even say 5. It doesn't really matter. We just want to make sure to increase it. So I will send the same event to the Captain control plane. The Captain control plane will again trigger the Helm integration, and Helm will deploy it, and we can already see 2 more instances coming up on our Kubernetes cluster in the LitmusChaos namespace. They are not yet ready, so we will also not see the deployment finish event in the Captain's bridge until they are ready. We saw it in the previous version pretty fast because the same version was already deployed, so Helm finished pretty quick. Maybe this is not reloading. So here we go. First one is already up and running. Second one is also here. So we will see in the Captain's bridge everything's fine and the deployment is finished. As I've told you before, once the deployment is finished, Captain will trigger the tests. So we can see the Chaos runner has already been started, and the Chaos runner executes the experiment and has been added to Captain. In our case, it's a pod delete. It's the same experiment. We are just running this again as part of our pipeline. So we really shift left into the pipeline with our Chaos experiments. So this one is now starting up and will randomly kill one of our pods of our Hello service here. The configuration is in the way that it will kill one of those. So we could just see which one, the terminated one. So this one will go away and the other one will come up. And just be reminded, in the background, it's still load generated by our JMeter service. It's still load generated on the service. In this case, we would assume that since we have now a replica set of 3, both 2 pods survived, so they could take all the load of the service. So we would assume that the resiliency score or our SLOs should stay quite high, since it's only 1 pod that got deleted, and the overall service quality should be satisfying. So let us take a look in the bridge. We can see here another test run, configuration change, deployment finish. We already have seen this also in Lens, and we just wait for the tests to be finished. So in the previous run, it took about 2 minutes for the tests to be finished. I would assume the same also for this run. And again, once the tests are finished, Captain will reach out to the SLI service. In our case, it's connected to Prometheus. We'll fetch the SLIs, and then based on the SLIs, it will score it. So we already have it. And in this case, we got the score. The probe success percentage was 100. So the pod that was killed never received, or did not cause any issues. And also our probe duration is now lower than these 100 milliseconds that we expect. So we can really see with this, we can do very fast iterations to evaluate resiliency, and we can even tweak it either by taking a look at our SLOs or doing checks or doing changes in the quality of the service. All these files are actually, for example, the SLO file is just this file here. It's not a very long file. It's just 25 lines. That's the whole quality gate. And we can even tweak this. We can make changes and just provide it to Captain again. Captain is based on GitHub, so it will be stored in the Git repository, and this is how it works. So I believe it was a very short introduction, but I hope that you could get the idea of this integration. If you want to give it a try, it's very easy to install. Once you have Captain installed, you can just add your service by just doing a kubectl apply with the service. The link is also passed here. And if you think that's really a valuable integration and usage of LitmusChaos, then be assured we are still working on this integration, making it better. And also what I'm really looking forward to is having LitmusChaos as basically a test to build self-healing applications. If you can think of throwing some LitmusChaos experiments on your applications and then having already some prepared auto-remediation scripts, I think that could really show some magic in your self-healing applications and build some self-healing architectures. Yeah, so I also put in here some links if you want to read the blog from Kartik. It's a really great piece of content. Also the integration of the services here. I will share the slides with you, so you also have it in your community. And I'm happy to answer questions, but thanks so much for giving me the possibility to present here this integration between these cool CNCF projects.
Great. Thanks, Jürgen. Incidentally, I just posted the blog on the chat as well. So like
Okay.
Jürgen said, if you're looking for more details on the philosophy behind this integration, talking about why chaos in CD pipelines and how Captain is helping and what it brings to the table in terms of helping you evaluate resiliency, I think it's there. You can take a look at that. Thanks once again. It was a really insightful demo. I think next we'll go on to Jordi. Would you like to share your screen, Jordi? I think the node power off experiment. Did you get to hear about that?
Yes, 1 second. Actually, I don't have it prepared. Sorry.
No problem. All right. In the meanwhile, as Jody prepares the setup, is there anything that we want to take in terms of questions? Or Watson, would you like to just bring up the topic on conformance tests with probes?
Yeah, I need to know how much time I have. You know, it's for my presentation. It's probably going to be slightly controversial. So let me know.
Cool, no problem. Then, okay, let's take a look at what we have on the agenda. Apart from that, the next one was about the restrictions that have been placed by Docker. I think some of us have been impacted by that. Having said, we are working on getting the open source license or mode that Docker is trying to offer to us, to all open source projects in which the restrictions will not be placed. We have applied for it and they have got back to us with a response that they are taking a look at it. It might take a little bit more time. I'm sure they've got thousands of applications like that. In the meanwhile, there are alternate options for us to switch to a different registry. There are also options for us to have some kind of a caching layer or a translation layer in between. I just wanted to hear from the community and what do you think is the best way to tackle this? If you are doing something of this sort on your projects, what's the approach you've taken? Just more of an open discussion. So I think until Jordi is ready to share his screen.
I'm ready.
Probably
I'm ready.
weigh in on that. Okay.
Yeah, it's just they want to interrupt you, so.
No problem. I think then we can go ahead.
So can you see my screen?
Yes.
Okay, great, thanks. So I want to present you a new experiment that we have been working internally at Red Hat, and it was related to shutting down a node abruptly, and to see how the pod that was hosted in that node will react. So in order to do that, we leverage on the code that was done by a colleague of mine, Andra. It's a node restart. And what the changes were basically change the command that was used to restart the node to use one that was to power off the node. We are, let me show you the code. So this is the engine experiment. It's very similar to what is the node restart, but I want to highlight to you the main difference, which is this one. This is the command that is passed to the SSH client to force the power off. And just want to let you know, there's attributes here are mainly to make sure that the connection is closed quickly, because I've noticed in my test that without these two flags, what happens is the SSH command is hanged on the connection for quite a long time. And it basically renders the test longer, taking longer time than needed. So by adding this, it will disconnect after 1 second or 2 seconds, if you want to look at these two variables. And this last attribute here, this last command true, is because I also noticed that when it disconnects with an error. So if what happens is the helper pod checks the value of the command and it detects that it's not a 0, so returns, it basically renders the pod as in error state. By running this extra command true, we guarantee that the pod will always return positive value. Basically 0 return 0 value, and the pod will be completed successfully. So aside from that, there is nothing else to change. As I said, is a variation of what was done already for the node restart. Now, the particular part of this test is that we're running this in bare metal using QEMU and using libvirt. So to do that, we basically interact with the VM directly with the hypervisor using SSH as, and it might not be a case that might be applicable to other environments. So I was discussing before, and this case could be useful, but it needs to be tested in GKE or EKS, because this is an environment that we don't have internally and we cannot test it. That's it for me.
Cool. Thanks for the contribution, Jordi. I'm sure this is a useful test, and considering that most managed services behave in a similar way, they will bring back an instance. We should be good, but we will test it. Like you said, right now, we will go with some kind of supported platforms restricted to the one that you've been running it against, along with some documentation that's putting out that information clearly. And we will continue to do the interop against the other platforms as well. So I think this is a very useful one to have. And considering the fact that we have support for different kinds of pod scheduling policies for the chaos resources, you can either specify node selectors or you can specify tolerations. We are working on adding affinity and anti-affinity at a node and pod level. So that should help you to launch these chaos resources in the node that's not being affected without you having to change much manually. So these are good experiments to have and complements the existing experiments in the node suite, the ones like drain, taint, etc., and CPU and memory hog on node. And just as an FYI, I just put it on chat, we have been making some enhancements around how we're going to treat helper pods that are going to be in error state. There was some requests and some discussions that we had been having with Hoshwin, who is also on this call, on how best to avoid keeping orphaned helper resources. So we will be extending the job cleanup policy to the helpers as well. So it should help removal of the helper pods in both the abort as well as graceful cases. So once again, thanks for explaining this experiment, Jordi. Looking forward to more of these and hoping that Litmus is helpful in your environment.
Yeah, thank you for letting me present it, by the way.
Sure. I think going ahead, I think we can go to Watson. Would you like to share about your topic today?
Okay, how much time do I have? And is this being uploaded to YouTube? Those are my two questions.
No problem. I think we have time. I think the question on the Docker pull rate restrictions is something that we can discuss about offline as well. I'm sure there's going to be a lot of opinions and a lot of mitigations that are going to be suggested. So we will take a call on that. And
so like 5 minutes, 10 minutes, what are we dealing with?
Yeah, I think you have time till the end of this call. Should be around 17 minutes.
All right, cool. And is this being uploaded to YouTube?
Yes, it is going to be.
Okay, so you get the PG-13 version. All right. I'm sorry if I learned about this morning. I just saw the request this morning and said, okay, I need to put something together. I don't have a slide deck, but I'm going to give you all a background of the community that I have to deal with, and it's the telco community. I myself, my name is Watson. I'm with the Volt Cooperative. I work on various different projects for different CNCF initiatives, things that the CNCF thought were good ideas and maybe try a code spike on. One of them is CNCF CI. Another one is the CNF conformance project. But I think for this community, for the chaos community, I think I need to give some context. I myself, I'm a programmer of 30 years, so on, or so, professionally since 1992. So I'm kind of one of you all, just traditional application. Now we're doing a lot of cloud stuff, fine, right? Different backgrounds, medical devices, government, all this type of thing. But so I'm not a traditional networking, so I'm going to be talking to you about the telco community, not traditional telco. So I'm just couching this with I'm one of you all, but I'm going to give a critique right now just to give you the severity of the situation within the telco community. So background here, just to give you some of the expectations within telecommunications. Here's a switch here, a piece of telecommunications equipment. The AXD301 has 9 nines of reliability, right? So I challenge you to find something else with that much reliability, right? So that's a challenge right now for the chaos community to find that. Just being slightly controversial, this community, I'm telling you right now, they don't care about chaos testing. This was in 2002 where they got 9 nines. So they are very much like, oh, we're the experts on how to get high availability, right? So this is what I have to deal with, just to give you the background of where I'm coming from for the CNF conformance project, which I'm going to tell you about later, right? So here's the evidence, right, for this switch, 2002, right, 9 nines availability, 30 to 40 million calls per week. This is one or 14 pieces of equipment. Actually, it's one piece of equipment, 14 nodes or something like that. But the concept is telco believes when they go down, people die. If you were to talk to an architect at any one of the service providers, they believe that when emergency services can't be called, you can't call 911 in the United States. You can't call 911. Someone's life is in danger. Maybe they're going to die. So they think that they have to be up at the same level of what you would think, medical equipment and all that. But they think that their job is harder than everyone else's. So that's kind of where we're coming from with telco. That's the background, okay? So that's what we're dealing with. And then again, within this community, there's various different open source telco communities. They, as far as chaos testing, they're like, yeah, whatever. We've been doing this forever. We don't even use that language. So I've been tasked, and with the group I'm with, we are trying to say, in order to be a good citizen of the cloud native, and so on and so forth, you need to do all of these principles. One of them, breaking your application into microservices, and maybe use chaos testing and all this stuff like that. And it is an uphill fight because they're coming from this and they're saying, no, we know what we're doing. And so they're all about having everything in one big ball of mud and all of that. So that's what I'm dealing with. Okay, so hopefully that's clear and that's shocking enough to get people's attention. So the CNF conformance project, the CNF conformance project, like, again, so when they look at chaos and, like chaos testing, we think of what, Chaos Monkey, Netflix, and so on and so forth. And we're like, oh yeah, this thing that goes out into production and kills things. And they're like, oh, that's cute. That's what they look at it like. Oh, that's cute. But when you want real availability, you need to be talking to us. That's how they look at it. So now, as far as the CNF conformance, in a nutshell, it's basically, this is a grading system for trying to see if you do things with good cloud native principles. One of them, so we'll go over here. We have different categories. Let's go ahead and say there's compatibility tests, there's statelessness tests, and Litmus is in statelessness, security, microservice tests, scalability. We also are saying Litmus is in here as well. Configuration lifecycle, observability. Anything where we're dealing with, is your project resilient, right? We want to inject some type of chaos and test it. Again, the telco community is it's kind of foreign to them. They don't consider chaos as a first-class citizen. They have testing, but they're more about load testing, right? And they'll do it one hard time and then that's it. And they don't care about the whole concept of microservices is a fight. They want to take 50 processes, put them in one big ball of mud and say, we did it, we're ready to go. Put it all in a container or a set of containers, and we're done. We're now cloud native. And so that's the fight. That's what we're dealing with. And so bringing it back to some things. So this is a plea for help from you all, which I consider chaos community, trying to make chaos testing a first-class citizen within a telecom community. I need arguments and then code in order to say, here's what we need to do. So here's where the rubber meets the road. I'm going to try to fly through some of this. So that's CNF conformance. Let's go in. So we were talking about, and then we have some questions. I have some questions about probes. So chaos probes, right? So setting up a probe, it seems like, let's see here. There is the concept of, I switched away from the place where I actually was, but there's a concept of setting up a probe where it does a test, and you can do it in the beginning of the probe, the beginning of the chaos experiment or whatever, or at the end, so on and so forth. And when it comes back, I guess there's, what was it, an HTTP test? There's a command type test where you can kind of get really custom, and there's another test, I think. And that all seems great. Here's what my challenge is. Making some type of standard, and it seems like probes are somewhat of a standard, making some type of standard for networks to where we can say to someone that makes and I'm going to introduce a new language, a CNF, so a cloud native network function, something that is within networking, where it would be similar to what a probe is, kind of, where we are able to allow the vendor, so you all might be familiar with someone like a Cisco or an Ericsson or something like that, allow them to provide some type of code to say, here's how you truly send some network traffic through our product, right? And then test it. So it seems like probe seems to be the check after the injection or the actual real traffic, the replay or whatever. So that's my, so I think probe is one part of the solution. There might be another part that we can say, here's our standard that we think that you all should provide, because there's no standard for that. And I'm just really quick, I'm going to go through what their standards are for injecting traffic. NFV Bench is one. This is an open source project. There's a bunch of acronyms on here. I don't know if people would be familiar with, but within networking, within Kubernetes community, we tend to think of networking as what in the OSI model, layer 7, like application layer, maybe down to layer 3. Telco people care about layer 2. That might not matter for this, but they care about a little bit more than what the traditional Kubernetes community cares about. So pushing traffic through, here's a project. So NFV Bench uses another project called T-Rex, just to give you some example of the type of data that they want, 200 gigabits per second. That's what we're dealing with when we're dealing with networking and telco community. Then when they say that, oh, everything's working fine, they want these numbers. This is not, oh, Nginx is up. Like this is on another level of magnitude. They think of it as what they call line speed, the speed of the actual network card, right? And so last thing I'm going to talk about is this, which might be a solution that maybe we can try to work with Litmus in. It's called PCAP. PCAP is a way to capture network traffic and have it in a file and then replay it, right? So it's simply like a command like this one. This is one example of PCAP. It's a way of saving network traffic, and then you can replay it later, right? So something like that, if we were to put it in a probe or put it in some other concept and say, this is a concept for giving real traffic, and here's another concept for testing the traffic, that might be the probe. That's where we're dealing with. And last thing, what time is it? 11:26. Last thing, well, here's a page. I can put it into the chat. As far as real network applications, there are far more involved than like your traditional, say, Envoy proxy or something like that. There's a whole lot more. And just to give the real example, something like a 5G packet core would be a real cloud native network function. And this is the kind of thing where they say, oh yeah, that microservice thing, whatever, that's toys. We're going to give you a big fat binary and you run that. And we'll try to have our high level of availability and all that stuff. And we're trying to say, no, break that apart. And you need to test all those individual processes and all that stuff separately with chaos. That's what we're up against. So now, any questions? We've got 3 minutes.
That was awesome. Thanks for those insights, Watson. I think this is really useful coming from the community. And if we can use Litmus or any chaos engineering solution for that matter to really verify telco grade scenarios, I think that's probably when we're really doing what we're supposed to be doing. I just posted a link on chat about the Litmus probes. Probably, I think you might have already taken a look at it. So we have a couple of modes of probes, like you already mentioned, the ones at the start and the end, something that we're calling SOT, EOT, and Edge. But there's also a couple of other modes that we've introduced called continuous mode and on chaos mode. So this is something that you mentioned about not doing verifications after you've finished running your load or doing your chaos, but during the period of the chaos itself. So as you're doing the experiment or you're killing something, but at the same time, you're really seeing whether the SLO you might have in terms of network traffic or some metric that you want. And I am completely agreeing with you on the fact that you should probably write the standard in such a way that folks can write their own probes as it makes sense and easily plug in into the chaos engines, something that makes sense for the telco operators. The continuous mode should be helpful in terms of, I've put it up on chat, maybe you can refer that link there as well. The continuous and on-chaos mode should help do the checks just as the chaos is running. So that probably answers the first question. And regarding being able to run tools like the one that you showed, the NFP bench and the replay that you probably might have from the ping cap, there is a Kubernetes mode which can also do CRUD, Kubernetes probe, which can do CRUD operations. Right now, I think if you look at it in this document, it's probably not clear. My bad. We will probably add that documentation. And there's a couple of things that it's not represented here. One is the Kubernetes probe actually allows you to create some kind of a job or some kind of a pod, which is, for example, running some load. So if you want to run some load, just as you're doing chaos, you can actually use the Kubernetes probe to trigger that job. And if you are able to containerize your load generator in some way, then I think you could use the Kubernetes probe to launch it. And regarding the ability to standardize this to the next level and probably allow people to write their own probes is some very good feedback. I think right now we've not taken those efforts. We've sort of added it as some piece of code there and just expose the schema. But I think it really makes sense to provide a standard around this. I will take that as a feedback, definitely. And there's also another probe, which is undocumented. This is the second undocumented feature. It's called Prometheus probe. It is something that you can run in all these modes, SOT, edge, or continuous. And you can continuously check for a particular metric. You can run a Prometheus function against some metric that your exporter is pushing out and see whether it is staying at the level. Let's say you are supposed to reach 200,000 some value, some unit, right? Some bits per second from your application, from your CNF. Then you can ensure that through the process of chaos, it does not drop below that level. That Prometheus probe is under construction right now. We have a nascent version of it, which probably can be pushed out in a patch, but I think the 1.11 version that's coming out next month should probably be helpful. And I also saw Jürgen was interested during this conversation as well. So there's a concept of quality gating and SLOs that you can do with Captain as well. I think we would need to write up some kind of an SLI provider for the network functions. It would be really interesting to do that as well. So this is, I'm not sure if this is really a solution to the challenges that you just stated, Watson, but I think probably we will be getting a couple of steps closer to the solution with the continuous mode of the probes and the nature of probes like Prometheus probe and the Kubernetes probe creating some kind of a load gen, just as you're running chaos. And we can also support something called probe chaining. That is, you don't have to have a single probe defining the steady state for your experiment or defining the hypothesis for your experiment. You can actually have more than one probe listed in the chaos engine, and you will get a combination, a combinatorial effect where you can actually see more than one criteria enforced against the success of the eventual success of the experiment. So probably that's something that we should talk more about. That's something we should document and also get back to you on an example of a continuous probe, along with ability to run some load gen while probably you're checking for metrics, all three at the same time. So I think that's something we should construct and get back.
Yeah, and there's a telco CNCF telecommunications user group that the language that you just used and the arguments that you just used should be presented in there by this chaos community instead of someone like me, right? So I think that would be good. And there's also the the Cloud Native Telco Working Group that these arguments should be also presented in, and saying, hey, in order to really strictly, rigorously test your resiliency, you need to be using chaos testing, and then for these standards, right? So I'm not like the only voice for trying to push this stuff forward. But yes, the continuous probe will look at that, and I'll try to put some of this forward. But I'd like to get some help from you all.
Sure, I think that we're definitely with you on this, Watson. I think we are 3 minutes past, but just on the CNF conformance, we had another update. I think Udit is on the call, I hope. And yeah, Udit is on the call. And he has been setting up a local testbed and trying to whip up some crystal scripts for running the chaos experiments. Hopefully we should be good to upstream that soon. Udit, would you like to share some update or maybe share some challenges? I think Watson is here, so it's good to give an update.
Yeah. Thanks, Karthik. Hello, everyone. So I just tried, there are a number of tests I explored this CNF conformance project, and I just tried adding some litmus test in it, and I was successfully able to add the pod delete test and run a chaos on a sample application. Do we have a time to show that, Karthik?
Not sure, but if we can sort of put it in a Google Doc and share it on the channel, I think that'll be helpful. If at least that will validate our approach, and probably we can upstream it quite quickly if things are looking good.
Yeah. Okay. Then we will. I will document it and we'll share it. Then yeah.
Thanks, Tom.
Thanks.
Okay.
Thanks.
I think that's all we had. I think we will probably open up the discussion about the Docker pull restrictions. I'll keep you all posted on the response that we're getting from Docker Hub. Please feel free to weigh in and just start a thread. I think there's already one that Jordi has started, so feel free to post in the opinions there. And the release notes for 1.10 is out. Please feel free to take a look at that. On 1.11, I think a lot of things we just discussed as part of our discussion with Watson. Continuous probes, we will be continuing to enhance, add Prometheus probe, probably make some more documentation and use cases available, examples available in our docs around that. With that note, I just want to state one thing before we all sign off. There is a survey that we put out in the Litmus Slack channel for our documentation. We're trying to revamp it, move to Docusaurus 2, add more examples and add more sections around discussing Litmus architecture, and probably make our, probably move away from Nginx as an example app, things like that. So if there's anything that you would like to see being improved in documentation, please go ahead and take that survey. Your feedback is very important. We've got around 10 responses now. A lot of useful information, a lot of useful feedback, but I request you to chime in with more thoughts. And thanks once again to all the participants for joining in, for staying up, and sharing all your opinions. I think the conversations that we've had on Slack are really useful, and they're powering our next set of features and fixes, enhancements. So keep them coming, and hopefully we are able to meet your expectations around running chaos. A lot of good contributions coming in from folks like Jordi and Andra and Summer. All of you, thank you once again for all of that. I think that's all we have. Enjoy the Thanksgiving day and the weekend and Christmas after that. And we will meet, I think we will meet before Christmas, hopefully. And yeah, I think happy holidays and have a great weekend.
Thanks.
You too. Have a good one.
Thank
Bye.
you, Karthik.
Thank you,
Bye.
Karthik.
Take it easy.
Thank you.
Bye-bye.
Bye.
Thank you. Bye now.
Thanks a lot.